So we are on our last speaker. So someone who does not need much of an introduction, my partner in crime, Dr. Alberto Caban-Martinez, who's going to give an update from the Firefighter Cancer Initiative. Dr. Caban-Martinez is an occupational epidemiologist, osteopathic physician, associate professor of public health sciences at the University of Miami Miller School of Medicine, and deputy director of the Firefighter Cancer Initiative. Dr. Caban-Martinez also serves as the Vice Chair of Research, Assistant Provost for Research Integrity, and is the MD MPH Deputy Director for the UM Department of Public Health Sciences. His research interests include monitoring carcinogenic and workplace exposures throughout firefighter careers and examines their impact on firefighter health. He has recently been inducted as a Fellow of the Collegium Ramsini, a prestigious international scientific organization focused on occupational and environmental disease prevention. So without further ado, Dr. Caban-Martinez.
Let me just say before I begin that I know that between you and a beer is my talk. So I will be brief. This afternoon, it is my privilege to give the annual update of the work that we've done through the Firefighter Cancer Initiative. And the work that I'll present to you this afternoon, I stand on the shoulders of many different scientists, clinicians, and firefighters that made this work happen this year. The work is an update of what we've done together. As always, I'd like to dedicate the presentation to people that have had an impact on us. As a scientist, I think, we work with our colleagues. We have our senior mentors that guide us professionally as we do our own professional development and our work. But in my world, where we do public health and occupational health, it's the communities that we serve that impact us. And since I've started this journey 9 years ago, there's a couple of firefighters that many have affected and informed what we think about, but several that have impacted my own personal development and thinking of how I can protect firefighters from cancer. And those are here on stage on the slide. Lieutenant Julius from Miami-Dade Fire Rescue, driver operator Rafael Garcia from Miami Fire, driver engineer Polly Piafetras from Coral Springs, firefighter paramedic Nate Leonard, Coral Springs Parkland Fire Rescue, and most notably who catalyzed a lot of this is Lieutenant Butch Smith. So this is for you guys. I'm also remiss by recognizing firefighters that inspire us day to day. And I want to note two that have impacted me. One who gets to be here with us today, and then others that are currently right now working through it. Captain Richie Hudson and his wife, firefighter Gina Hudson, who are currently working through a challenge with cancer, and a very inspirational firefighter who got to spend hours and hours with me at the DCC and really made me look at cancer in a different way. Firefighter David Perez from North Collier Fire. Thank you for what you do. So for those of you that are joining us from far, either from other places of the United States or from international, please know that the Sylvester Comprehensive Cancer Center at the University of Miami serves as the home of the Firefighter Cancer Initiative, and where all of the work that is done, and I'll show you in a minute. It really got started, as Dr. Kobitz was saying earlier this morning, and Director Rice and Hallis, about putting together people to talk about how a committed group of people can make change happen. And in public health, that's hard. But in 2015, due to legislation that was done here in the state, and at the time, State Representative Jeanette Nunez, who's now our Lieutenant Governor, was able to, with our firefighter partners that we listed there, are able to give us the support to generate the funds and the awareness of answering the question to understand and address excess burden of cancer in the fire service. Our goal is holistic, and trying to begin from beginning to Z of how we address this question. So since the FCI got started, what we try to do is identify through our firefighter research and retreats what novel translational research needs to be done to address what's happening at the workstation, right? So at a fire station, what do firefighters need in order to prevent themselves from cancer? We also develop and adapt educational and preventive initiatives to do so, and then obviously collaborate with the firefighters as they inform us of those designs. We've been fortunate since the inception of the FCI to acquire funding not only from within the state, but from outside the state with different federal funding agencies that have advanced the research work that we've done through FCI, including private donations from funders that accelerate this individual work. This work is done through partnerships. As you can see here, we work with different municipal, state, and federal partners, affinity groups of firefighters, in order to be able to take this education, research, and service out there. And in this last year, we've been able to engage over 8,000 firefighters through various Firefighter Cancer Initiative projects. And most recently, as we concluded the COVID-19 pandemic, help our first responders with rehabilitation and return back to the work. We currently have 22 active projects. We've completed 11 projects, and 6 are national projects outside of the state of Florida. I'm going to talk to you a little bit about how we think about cancer research in our space. So it's a complex issue. So it's just like Dr. DiMarina and Dr. Main mentioned this afternoon, we start with biology and understand the basics of biology and how biology informs what can be happening in a fire station. We also think about prevention. Can we have firefighters that never even develop cancer? That's our goal, right? So what projects go towards there? We also want to figure out, are there unique and special ways that we can use to do early detection and diagnosis? And how is that early detection and diagnosis different from what we might do in a civilian person compared to a firefighter known with the given exposures that they have, and ultimately impact their work? So I'm going to present to you, so I apologize to my scientific colleagues who are going to leave them hanging with a lot of details of the research project. My goal is to show you some of the breadth and scope of the work that's being handled by my colleagues through the Firefighter Cancer Initiative. I'm going to first walk you through some of the epidemiologic work that's done at the state and the national level, look at the cancer registry, then we'll loop over into some environmental sampling and exposure assessment, and then we'll close with some of the innovative projects that we're doing, cancer screening, education, and survivorship. So I'll start with the registry. You heard this morning from Dr. David Lee, our senior scientist, and the cancer registry. They play a very important and unique role. They let us get to what are the people that are having cancer, and how are those people different from our firefighters? What types of cancers are they experiencing, and the severity of those cancers? So Dr. Lee and the teams, and I just want to acknowledge Dr. David Lee and Dr. Tulay Koro-Sungal, who's here in the audience with us as well somewhere, who work really hard to bring together data with the support of our State Fire Marshal's office in identifying who are firefighters and comparing their cancer experience to the cancer registry. And so what you're seeing is a group of years together from 1981 to 2014 specific to our Florida firefighters. And what's interesting here is that they stratify it, or they break it up by our male and our female firefighters, and are able to show, okay, what type of cancers do we see are slightly more elevated? So if that AOR, the column that says AOR, adjusted odds ratio, is above the number 1, we like to say that the firefighter might be at risk, or the odds of developing that type of cancer are a little bit higher, and it's significant. And so you can see that for male firefighters, melanoma was 1.56. 1.5 or 1.6 times more likely to develop cancer. And when we look at our female firefighters, it's 1.7, but it didn't make it to be statistically significant because it doesn't cross 1. But looking at these numbers informs the epidemiology of what we're seeing within our Florida firefighters. And oftentimes we find ourselves, particularly in this last year, working with other states to help them support the development of this type of strategy and how to identify the cancers that are happening within their state level firefighters. The second part of the table shows you the continuation of other anatomical areas. To your left, you'll see that male firefighters during that period were at a great increased risk, 1.3 times more likely for prostate, 1.6 times more likely for testes, and interesting also, two times more likely to have a diagnosis of thyroid cancer. And when we look at our women firefighters, we see that brain cancer was elevated as well as thyroid cancer. So this epidemiology is really important about how we know our numbers, right? Otherwise, if you develop an intervention, you won't know if you're making any impact looking at the cancers that are ongoing. In the past, I've shared with you that we also do what's called the annual cancer survey. The ACS is an epidemiologic long-term survey that started in 2015, where we collect survey and biological samples to measure exposures and its relationship to health and health behavior within our firefighters. This year, or a year and a half now, we began to develop a report back letter system. We heard from our firefighters, well, you know, we see your summary statistics, but I'd like to know what did I do compared to my colleague firefighters? And so we developed what's called a report back system. And I'm thankful to Dr. Brandon Rose, who's probably in the hospital seeing patients right now, but helped us code all the data. Oh, Brandon's here. Stand up, Brendan. So he was able to code and automate the process of creating report back letters for our firefighters so that they can individually see their individual results compared to what they have in their fire station and to all Florida firefighters. And so this report back system is new and continues to be developed. As you heard from Captain Ziegler this morning, partnership is essential. How do we reach out to fire departments that want to be able to engage in cancer research for firefighters? So I'll encourage you in just a couple of minutes to go back and meet Johanna Garibaldi, who you saw this morning with Captain Ziegler, and look at the research work that they did with the O'Neill Cancer Center in running the annual cancer survey in their fire department, and what they're learning about both individual firefighters as well as organizational level with their policies and practices and awareness. So you've heard me mention before that when we started doing the FCI, our retired firefighters said, we're the ones getting cancer, but you're not asking us any questions. So what what science and projects can we do? So I'm actually asking you all for help. We need to find retired firefighters because they are challenging to find after they've retired. We developed what's called the Aerial Cohort Survey. And the Aerial Cohort Survey is very similar to the annual cancer survey, but is designed to enroll and follow long-term retired firefighters. So right now we have about 945 retired firefighters within the state and outside the state of Florida. So if you're from anywhere, you're welcome to use the QR symbol to scan and take a look at that survey. It gives us meaningful information about the cancer and cancer risk behaviors of retired firefighters once they've left the fire service and are hopefully living a good retirement. A study that was just published using this data by my colleague, Mr. Addison Testoff, was using the aerial data from retired firefighters to understand the experience between sleep latency and post-traumatic stress disorder among our retired firefighters. And so his goal in this study using aerial was to look at what is the relationship between firefighters and their onset of sleep, like how long it takes them to get to sleep, and any experience with post-traumatic stress disorder. So he used data from the 2017-2021 baseline survey. He defined PTS risk using a 4-item primary screener for PTSD, and then he defined sleep latency as greater than 20 minutes to fall asleep. And so what he found within that data set is about 8% of these retired firefighters screened positive for PTSD risk, and about 37.6 had experienced prolonged sleep onset latency. So imagine you're in retirement and about 37.6% of this particular sample had sleep onset latency. And so what he found when he did the math is that around retired Florida firefighters that had PTSD risk were almost 2.7 times more likely to have prolonged sleep latency and take longer in order to find a sleep. So this data is really critical to understand not just what happens while you're a firefighter, but in retirement, as many of these behaviors and exposures that lead to sleep latency issues, sleep quality, might ultimately impact post-traumatic stress. With our colleagues and our firefighters here in South Florida, with the IFF, OSHA, and FEMA, our local 1403, we were able to help and support during the Surfside building collapse, and we developed a safe, what we call the SAFE cohort, which is a biomonitoring program that was designed for urban search and rescue firefighters that responded to the building collapse. And those assessments are ongoing and being completed, but the cohort invites and consents a firefighter to participate, administers a survey at baseline. We collect some biological samples. We use toenails for measuring heavy metals, and then we repeat those biomarkers over time to see long-term what those changes are. And so in the near future, after we've had a chance to meet with our teams, I hope to share those results with you. I'm going to switch over to our teams that work on environmental sample and exposure collection and share with you 3 really new projects that we've done in the last year and a half. And those are on serum PFAS, measuring gear PFAS, and then measuring heavy metals. So my colleagues already mentioned, you've learned a lot this morning and this afternoon about PFAS. There's a whole family of them. If you've, like the Fernandez and Rodriguez family, we got a lot of our members in there, right? So PFAS has about 4,000 of these chemicals, both short chain and long chain. And so as Dr. Stapleton was mentioning, like it's very difficult to quantify so many different things and also link them to health effects because there's so many different types. And they range in their half-life of how long they're actually within humans. And as been mentioned earlier, they're in many of the different products, right? So they're in paints and shampoos, fast food packaging, firefighting foam, and inner liner. And so we're interested in sort of, our Florida firefighters asked us to characterize this and what type of PFAS levels we see in the serum of those firefighters. So last year, we actually teamed up with two Florida fire departments, one in the north part of Florida and then one here in South Florida, and just did a blood sample. We teamed up with NMS, which is the lab in Pennsylvania that runs the same samples for Department of Defense military firefighters, and said, would you run our firefighter samples? We looked at 7 congeners of the PFAS, and you can see that there is definitely variation of the serum PFAS in this random 100 sample of 108 firefighters. The red column represents the firefighters in this fire department. The orange represents those that are DoD military firefighters. And then the green represents those that are Americans like us, non-firefighters. And so obviously some of them will stand out to you as like, well, the American population seems to have more higher PFAS of certain of the congeners compared to the others. And this is by chance, right? We did one random experiment, invited up to 108 firefighters, and this is what we see there. Now, what was interesting from this data is if you actually turn the lens and you look at it based on what type of firefighter are you, for example, are you an airport firefighter, fire investigator, incumbent, probie, or retired, we start to begin to see a different picture of the serum concentrations of PFAS. So it suggests, but doesn't confirm or anything, that maybe certain types of activities that you do as a firefighter increase or decrease that risk for exposure. Again, you could be living at home with PFAS running in high concentrations in your water, but in this particular sample that we did, we do see variations of those PFAS based on the type of firefighter. So again, we did that for another fire department closer here to South Florida, and we saw again variations in the type and concentration of those PFAS depending if they were the sample, NMS and NHANES, usually with the American sample having slightly higher. And when we again changed the lens to look at it by the type of firefighter role that you play at a fire department, we could see tons of variations of the concentrations that were there. Most interestingly, the fire instructor across both of the departments and the fire investigators had the higher concentrations of those serum levels. This semester, we're launching a feasibility study of PFAS, so we're working with Eurofins to use the Mitra kit and postal mail the kits to the firefighters and be able to characterize 40, including Gen X, of these firefighters with the goal of being able to increase our ability to reach out and characterize the PFAS that we see in regular career and volunteer firefighters. And this semester, we're also launching a national firefighter PFAS registry. So there is a difficult opportunity, there's a difficult challenge as a scientist to try to find samples of PFAS and which firefighters have what levels. And so our team has been working together, thanks to Alex Cruz and Natalia, over the last year and a half, speaking to different experts in the field and laboratory, firefighters, chemists, to try to understand what components of a registry would be needed to document PFAS and what should be collected and how should be collected. And so we put that together this year and a half, and we'll be launching this semester a web portal where firefighters can submit their PFAS information and exposures. Another study that was done by the exposure team is the gear PFAS study. So this was a collaboration with Florida International University in trying to figure out if there's a non-invasive way of measuring PFAS off of gear, right? So we, as scientists, might want to cut the gear, right? So we can run it through our processes and sample it, but we really can't do that because you need your gear and you don't look good when you have holes in your gear. So we were trying to figure out, is there another way of being able to do that type of catchment? And so the concern stems out of like aging gear that might be able to leach some of those components, as well as some of the foams that are used in there. And so obviously, like I just mentioned, it's very difficult to try to take out this PFAS if you can't cut out the gear. So we wanted to be able to find a way of doing it and being sensitive that we're not cross-contaminating samples that are collected off gear with other areas where PFAS might be laden and there. So we ended up using, in this particular pilot study, a sample of polypropylene fabric as a swabbing textile. So we take a particular type of textile, just cut it into little squares, and then we use those squares to be able to sample off of the gear of firefighters to see what can be collected. So here was the process. We took 12 sets of turnout gears from a local fire department, and we swabbed it with the moistened polypropylene fabric swatches. We gave them circular motion, 10 seconds for each swab, and tried to be uniform within there. We did the SCBA masks, one swab on each side, inside and out, a turnout gear coat, one swab on the right and the left shoulder, and then one swab of the right and the left shins on the turnout gear pants. So each gear got a total of 6 swabs per turnout. So our colleagues at Florida International University, Dr. Natalia Suarez, ran it through LCMS and was able to identify variations of the different types of PFAS from those swabs that were collected. So you can see on the graph the different bars which represent concentrations of these different PFAS based on what she was able to detect, whether on the inside of the SCBA, outside of the SCBA, on the shin, or on the shoulders that were sampled. And then when we look at the total PFAS concentration, so not necessarily looking at one particular PFAS, but just the sum of everything across those different 12 turnout gears that were tested, you can see that there's different variations in the concentration of those total PFAS on the gear. So for example, in gear 1, you can see that the highest concentrations were found on the shin and shoulder samples that were obtained versus the inside and the outside of the SCBA. And as you go across each of the gears that we tested, like 2, 3, and 4, you can see that there's differences in those total sum concentrations. The other interesting thing is exposure the same among all the different firefighter gears? So each of these columns represents one of those gears, and you can see chromatically by color that, for example, this is all the same gear from the same department, and we don't know the age of the gear, so if it's younger or older. But just in the swabbing process of going across the 12 gears, we noticed that you can see in gear number 1, a very high concentration of PFAS outside the scuba. And then as we go to the greens and blues, that there was varying concentrations of total PFAS, suggesting that there's variation depending on what the gear goes through and how it goes through it. So the third study is heavy metals. There's been increasing interest to characterize the metals that firefighters come across, particularly now with electric vehicles and understanding how they do that. So my colleagues, Dr. Shanta Dar and Mr. Alex Stewart, have been conducting some pilot projects in assessing heavy metal in the toenails of firefighters. So bear with me one second. This is a graduate student project. Heavy metals are usually metals that are more have high densities when you compare them to water, and in some cases they're essential for human life, and in other cases they can be detrimental. Right? So for example, copper, selenium, and zinc are really important metals to human physiology, but then other ones such as cadmium, lead, and mercury can have detrimental effects. So in the general population, we can come across these heavy metals in many different places, right? So and outdoor dust and traffic sources, you can get it from cooking and painting. So it's hard to, identify the point source, but we're interested in what did you come across when you, over time. So we worked with IFF at 2 different conferences, both ALTS and the Redmond-Barbera conference, where we invited firefighters from North America, both Canada and the US, when they were doing a survey, hey, would you mind giving us some toenail samples? Then this is why we have graduate students. So 54 samples were collected from Nashville, Tennessee, and 40 samples were collected in Orlando, Florida, both in 2019 and 2020. And this is what we find. So this schema is a heat map that shows the concentration of the metals for every toenail sample that was collected. So you see on the x-axis at the top that we have sample 1, 2, 3, 4, all the way to 60. And then on the y-axis, you have the different types of metal, lithium, beryllium, magnesium. You can see calcium is very red, right? So the darker the red, the more crimson red, the more concentration of that metal is present. So calcium's important. You need it for your nails, right? Now, nails are interesting because when you ask an individual for their nail clippings, the nail clippings represent exposure from about 6 to 9 months ago, right? So if you're trying to character, it's just like rings of a tree, right? You cut a tree and you can see like if something happened in the life of a tree at a certain period of its time. And so toenails are very useful to us because they allow us to see the history of what a firefighter went through, say about 6 to 9 months ago in terms of their heavy metal exposures. And so thanks to Dr. Dar, Alex, and others, we're now being able to start to characterize that there. Thanks to our biochemistry team, and this came from one of our South Florida fire departments, they wanted to know, well, what happens when you like touch and play with foam, like the AFFF foam, and you use it? Is it harmful? So our colleagues in biochemistry did a study to evaluate how exposure to a cellular exposure to foams might impact the cell's proliferation, its ability to proliferate or grow, and its cellular mortality. And so the experimental design was pretty simple. We went to a fire station. They provided us with samples of the foams that they were using at different types. So there was one that's AFFF at 3%, AFFF at varying concentrations. They were placed in a petri dish at 0.3 and 3%. And what you're looking at is cellular toxicity, right? So the higher the concentration, the more cellular death that is seen of using that FFF. And these are human kidney cells. So that they're healthy human kidney cells and they're exposed at these different concentrations. And so this is insightful to look at what's happening at the cellular level. Okay. Another project that we're doing on the exposure side is with our wildland firefighting. So in this year, FCI has started to branch out and looking at different subgroups of firefighting workforce. So we've been working very closely with our Florida wildland firefighting colleagues. This project is led by our student, Umar Bakali, with mentorship with Dr. Sylvia Donner and Sapna Deo, Emery Dikichi, and others from our biochemistry team, where we've been collecting samples using wristbands with the wildland firefighters during prescribed burns so that we can see what happens in a more controlled environment. To do that, they were done in different locations, one in Lake Wales, Florida, and the other in West Palm Beach, Florida. And so one of the things that Umar has been documenting through using these wristbands with the wildland firefighters has been pH exposure has been mostly high with the lighter, lower molecular weight pHs like naphthalene and pyrene in these events. So what you're looking at here are heat maps that show the concentration of these polycyclic aromatic hydrocarbons based on the wildland firefighter. So each column is a wildland firefighter that wore a wristband post-burn, and he's able to document the type and concentration of those PAHs during post-burn experience. And you can see that these two different sites gave very different pictures of the aromatic hydrocarbons that were during that prescribed burn. Largely a function of probably the vegetation that was burning. We also have been working very closely with our fire investigators, thanks to Jeff Polly, Dr. Barbara Millet, and others, in trying to measure the exposures of fire investigators. They tend to be on scene longer than a firefighter and often don't wear PPE. So we're very curious about what are the exposures that fire investigators come across during that investigation. And so Umar was able to deploy wristbands and to measure polycyclic aromatic hydrocarbons. And you can see the variation of the PAHs that fire investigators collected through their auditing of an individual site, right, across those. So this initial preliminary findings suggest that there's exposure to off-gassing that occurs during post-fire, and it complements really well some of the work of our colleague, Dr. Gavin Horn, that has been documenting very similar findings. I would be remiss without saying that this year and a half, Dr. Barbara Millet, who I think is with us in the audience and will be presenting during the poster session this afternoon, worked with Jeff Polly from the International Association of Arson Investigators to develop a personal exposure record app, unique and special to fire investigators to document accident and near miss. So we want to know what are the carcinogens and exposures that fire investigators encounter when they're doing their auditing and root cause of their investigation. And so I'll close with the third project. Yes, I had 3 cups of coffee at 3 o'clock, so if I'm talking fast, you know what happened. So cancer screening, education, and survivorship. So thanks to my colleague, Dr. Natasha Sali, this year during the firefighter retreat here in Florida, they told us it's very important to develop a toolkit that harmonizes and centralizes all the information we talk about, because we do a lot of different projects, and they'd like to be able to have it available at the click of a button. So we've been developing a digital toolkit that's already available at the App Store if you search for Firefighter Cancer Initiative. This toolkit is designed to be able to give firefighters the latest information on cancer education curriculum and materials. What are the active research projects and what we're learning through there? What do you do if you have a cancer diagnosis? And what are resources that a firefighter could pursue outside of their department at the municipality, state, and national level, as well as events that are going on. So you see on the right of your screen a snapshot of what that toolkit looks like. And we're incredibly thankful to all the firefighters who spent hours and hours with Dr. Sally, making sure that we tweaked it and was relevant to what they needed and how they needed it. We've also developed an online portal. So it's not just an app, but you can also go to the URL that you see there, and you can sign up for the FCI's Education and Survivorship Program that have now been formally launched and are available online. These are the specific modules that are inside the educational course. So there's a lot of self-learning on videos, evaluations, and voiceovers that go through each of the learning objectives for the firefighter cancer curriculum. And then you can also, for fire departments that are interested, can work with us to be able to put it in target solutions and deploy it within their fire department's system. So the last slide is to tell you where we're headed. So we hope that to continue to advance the FCI through understanding the different exposures, risks, and cancer outcomes of different firefighter subgroups. The firefighter family is large and diverse, and special attention needs to be paid to those firefighters that are less investigated, like our volunteers, our women firefighters, and these other firefighter subgroups. We need to look at the relationships between mental health, stress, and cancer risk, particularly during large events where we're asked to quickly biomonitor what's happening, right? We need, one of the things that we're going to do with FCI is be able to be nimble and responsive to firefighter requests for measuring during high impact scenarios. We're trying to use new biotechnology to do early cancer detection as we develop those objectives for this year. Pursue additional research on carcinogenic chemicals, right? So PFAS and gear and foams and their effects on firefighter metabolism, how that's changing. We're also investing more time in looking at aerosol particles and lung cancer risk and understanding how aerosol particles are released and move through it, and ultimately climate and environmental health impacts. As the world continues to change and we experience more heat, more wildland fires, it's important to make sure that the research adapts to the needs of those firefighters. So we thank you for your time. Hopefully today was a day full of information. I am thankful to all of our IARC monograph working group members that traveled from near and from far to be able to share with you the latest science and understanding of cancer in the fire service. Now join me in a cold beer out in the back as we walk through different poster sessions and learn a little bit more from our colleagues that are presenting additional science on firefighter cancer research. We see you tomorrow. Do we have a, Yeah,
I was just going to say, so we know tomorrow we will be at the MDFR Training Center. So the addresses are in your book. For those staying at the Intercontinental and the Blue Lagoon, we will have shuttle service, same times, leaving again and going to the venue. Tomorrow it is all workshops. So it will be firefighter workshops from 8 a.m. to noon, and then your day ends, and then a scientific workshop that will go until 4:30. All are welcome to join either the scientific or the firefighter workshops. I think that's it.
That's it.
If any of the speakers, there was an invitation for dinner for this evening for all speakers. I know some may have not gotten it, so if you have not, please find me or Alberto or June from Twin Strand, and we can give you all the details.
Right. Thank you very much.
Thank you so much.